So guys, solutions to the exam questions, right? Talk through it. Now, first one, construction. Now I've told you, I've sent you on the YouTube clip where all the constructions are anyway, but just to clarify. So it tells us the PQ is 9, so I have P. I get my compass, I get my compass, and I measure an arc of 9 centimeters. Okay, I can't measure with the ruler, that's the point of a construction. Then it tells me that SPQ is 65, I think, in there. So you put your protractor here, measure 65, you have a dotted line up. It gives us that PS is 5. Again, I get my compass, measure an arc of 5. I draw a horizontal line across. Because it's a parallelogram, this is 9 and that's 9. So again, I swing my arc. And finally, I come back down to meet Q. Right? Then it asks me for the area of it. Now, the area of a parallelogram is in our log tables. It's the base by the height. Perpendicular height. So by perpendicular height, I mean that height there, not 5. So because this is a construction, you can actually do it two ways. I could get my ruler on the day of the exam and measure from here to here, and I could go 9 multiplied by, I call that x. Okay, so we go 9 by x, and that's my answer straight away. Or if you wanted to be, I suppose, smart about it and wanted to use I can make a right angle triangle here. Okay, using this. I know that angle in there is 65. I want to find that there. So I could possibly use ratios. Okay, sine, cos and tan. X is opposite 65. 5 is the hypotenuse. Oh hell, sine of 65 is equal to x over 5. 5 times the sine of 65 is equal to x. I would still go 9 times whatever x is, but I'd have a construction. Now, because it's construction, guys, you can just take it off that. I'd stick to that, okay, for the time being. Now, this diagram down here, this is one of the circle theorems that I sent you on things you have to know. Because this is the centre of the circle, that's a triangle inside in a semicircle. That means automatically I'm always looking for that angle up there is 90 degrees. The other thing you always watch out for in a circle is any line from the centre to the outside of a circle is a radius. So watch what I do straight away. Now I haven't even marked what they're asking me for here because I'm going to find everything. These 3 sides are all of equal length because they're all radiuses. That makes this an isosceles triangle, which means that there has to be 52. Okay. That also means because this whole lot has to be 90, I now know that this angle in here has to be 38. And notice the way this is an isosceles triangle as well. So these two angles are the same, opposite to two sides. So that's 38. Okay. So the answer to this question is alpha is 52. But remember, it was 2 beta, okay, down here. So beta is equal to 19. Because twice 19 gives me 38. Now from here I can actually calculate every angle because 52 and 52 is 104. 3 angles of a triangle add to 180. So that leaves this as 76. And then that has to be 76 plus 104 gives me 180. Also 38, 38 and 104 gives me 180. Okay, so watch out for them rules. 2018, again a construction. Okay guys, these are really important to come up every year. It gives us AB is 10. So again, I draw any line, I get my compass, I swing an arc. Okay, 10 centimeters. It gives me this angle here, CAB is 60. So I put my protractor down here, I measure 60. I haven't anything done yet. Then it tells me that ABC is 40. I put my protractor down on this side and I measure 40 up from here, where the two of them meet is C. It asks me to measure BC. Guys, because it's construction, ruler. Okay, straight out on the day of the exam. Parallelograms are extremely important. You've seen them come up over and over again in all these questions. Couple of key things we have to be aware of in parallelograms. Opposite angles are always the same. Okay, 4 angles altogether add to 360, so 115 and 115 is 230. That leaves me 130. I divide that in 2, 65 and 65. Also, that line and that line are the same distance, and these two lines are the same distance, so same markings on it. Also, a key thing to remember, it asks us here to prove that PQR is congruent to RSP. That means equal, identical. Okay, so the way I do that is PQR is this one here. I'm just going to draw a line across it. Okay, I know that RQ is the same as SP because it's a parallelogram, opposite sides are the same. I know that PQ is the same as SR because it's a parallelogram, opposite sides are equal. And I know that RQP is 65 and also RSP is 65. So what I'm using there is side, angle, side from the notes. Side, angle, side, side, angle, side. Okay, they both share the same side, two sides and the angle in between them. Okay, so that's enough to say, but also you have to give the reason for it. Construction again, AB is 7, get my compass. It gives me the angle here, measure it up, and it also tells me AC is 4.5, so I get my compass, I swing it down there, and there's, right? BC, because it's a construction, we can measure it, and the sum then is just obviously 4.5 plus 7 plus BC. Okay, whatever that was. Again, another key point, it asks us which one of these triangles can't be drawn. So the way I always start it is the longest side in any triangle is always the base. That's what I always go with, right? Now, let's look at this one here a second. So I'm going to go 15. Now, 6 plus 7 is only 13. So the shortest distance is a straight line between any 2 points. So if I swing an arc and it's 6, and I swing another arc and it's 7, no matter where the arc goes, these two lines are going to be getting further and further away from one another. So that they can't meet to draw a triangle. So one of the key points for a triangle to exist is the longest side has to be shorter than the other two added. So 3.2 and 2.9 is 6.1. So the longest side has to be shorter than the other two added. They're added together is 13. So that triangle can't be drawn, that triangle can. Finally, it asks us to use Pythagoras' theorem because it tells us it's a right angle triangle. I can always use Pythagoras' theorem because x is the only unknown here. So x plus 1 squared is equal to x squared plus 5 squared. Don't forget now, multiply this out properly using the array method. You end up with x squared plus 2x plus 1 is equal to x squared plus 25. Okay. Bring everything to one side. The x squareds cancel. I'm left with 2x minus 24 is equal to 0. 2x is equal to 24. Right, bring the 24 across. X is equal to 12. So that's 13 then. And finally, 2015, again, parallelogram. So I'm just going to fly through it. But I also want you to watch this one. Look, remember I talked about alternate angles. See that Z there? Because they're parallel. Because it's parallelogram. That makes that 30. Three angles in a triangle. Break it down as much as you can. Three angles in a triangle at 180, 110 and 30 is 140. So that leaves 40 there. Because opposite angles in a parallelogram are the same, that's 110. That means that has to be 40, and these two are 180 when you add them together, so that has to be 70. So you can just work your way around it. Don't forget the basic rules, okay, that I've said. Now, ABCD is a parallelogram. It gives me the area of it. Always remember, parallelogram is broken into two identical triangles, and the reason for that is half the base by the perpendicular height. They both have the same base. They both have the same perpendicular height. By perpendicular height, I mean that height there, look, the dotted line height. Okay, so the triangle ABD is 240 meters squared. Now I'm going to turn this around to explain the next question. Right, so that's for this triangle ECB. Now EC is half of DC, which means that it's half the base, okay, of that parallelogram. Okay, and that triangle. Okay, so then half of this is going to be a quarter. Okay, but it still has the same perpendicular height, so it's going to be a quarter of 480, which is 120 meters squared because it has the same perpendicular height. Okay. Hopefully that makes sense, and we'll work on more as we're going along over the next couple of weeks.